had gone out of control.
It was a terrifying moment. The explosion reached out so close to the blockhouses that they barely got out alive.
The leader of the firing party, Dr. John C. Clark, later recounted his experience. At 0 plus 20 seconds, a shock like a giant earthquake. At 0 plus 90 seconds, the air blast. So powerful that the concrete walls creaked. But it was their Geiger counters measuring radiation that spelled potential disaster. Bravo had created a vast plume of radioactive fallout, far bigger than expected and heading in a direction no one had predicted.
Fallout in a nuclear weapon is more a product of the material that's churned up by the explosion than it is of the explosion itself. The explosion is so hot that it just basically turns everything in the bomb into a gas. A bomb that's exploded on the ground stirs up the earth and irradiates the elements in those materials. And then that material is intensely radioactive. And its radioactivity is what typically we call fallout.
At the bunker, radiation levels were heading towards a lethal level. Clark knew that a helicopter would soon be on the way, but the men still had to get to the landing pad. The helicopter blades would kick up fallout which had already settled, increasing the danger still further, since the men hadn't been issued with protective clothing.
Get the bed sheets, get that one, get this one, get the one on the bottom.
And so they devised a primitive solution. These men, who'd just set off the most potent weapon at that time in history, would shield themselves from its deadly effects with bed sheets as they hurried towards the waiting chopper. The USS Curtis, 37 kilometers from ground zero, was now also in harm's way.
We were the closest ship to the blast. And that radioactive dust, it's like snow. They just ordered us below deck, and we went below deck and buttoned up. They came around with Geiger counters, and the Geiger counter would sing when they bring it around your body. I must have been down there 10 days. It stunk down there. It got really ripe. And if anybody went out of the hatches, you had orders to shoot them.
So what had gone wrong? Although the principle of the hydrogen bomb had been proved with Operation Mike, each new weapon was pushing science to the limits. Dr. Martin Kalinowski, a nuclear physicist at the University of Hamburg, was asked to examine the declassified data from Castle Bravo.
At that time, much of the nuclear testing was trial and error. And the test was their experiment to find out new information. And one particular information that is very important for nuclear physicists or bomb physicists are the so-called cross-sections, the capabilities of nuclear materials to react. Lithium consists of two different kinds of nuclei, lithium-6 and what is called lithium-7. 7 indicates that there is one more neutron in the nucleus. Physicists at that time thought that lithium-7 is kind of inert, it doesn't contribute in any way to the nuclear explosion.
You have to realize this, we were pretty ignorant in those days about cross-sections, and this wasn't thought of at all. We were ignorant of the fact, but we should not have been ignorant.
I looked at the cross-sections for lithium-6 and lithium-7, and the comparison reveals lithium-7 does have a high cross-section. That means a high probability of undergoing a nuclear reaction.
This particular fuel in this bomb was 30% lithium-6, 70% lithium-7. What the scientists were not aware of was that lithium-7 would be stripped of one of its neutrons early in this reaction as it blew and turn into lithium-6, at which point it would become bomb fuel. The weapon was designed to have a yield of 5 megatons. But because of this unknown reaction in lithium-7, it had a yield of 15 million tons of TNT equivalent.
The power unleashed by Bravo is still evident today. 3 small islands at ground zero were simply vaporized, leaving a crater more than 1 kilometer wide and 60 meters deep. And there were terrible human consequences too. This fishing boat, named Lucky Dragon, preserved in a Tokyo museum, bears witness to the killing power of the bomb. As dawn rose, the ship, with a crew of 23, was sailing 132 kilometers east of Bikini.
This white powder, like snow, began to fall from the sky. It was like a blizzard of fine snowflakes. But I thought, this is the Pacific. How can it be snowing? It fell on my head and face, and I licked some. It didn't melt like snow would have done. It was like eating sand.
Within days, the crew was suffering from acute radiation sickness. They hurried back to port in Japan, but despite doctors' efforts, the radio operator died. Others took a long time to recover.
There was a huge outcry in Japan. I mean, this was the one country that had already been atomic bombed, the only country in the world. For now, some of its ordinary fishermen to come home sick with radiation poisoning produced a national outcry.
The remoteness of Bikini Atoll should have prevented such contamination. We asked Dr. Kalinowski whether contemporary records can provide any explanation.
I looked at the weather data, and I think that is one of the main reasons why the fallout was higher than expected. We're looking here at the meteorological situation of the Castle Bravo test. Ground zero is marked here with this black star. The lines indicating so-called trajectories. So these are the paths that particles would follow within 24 hours after the explosion. The red line indicates a particle 10 kilometers height, whereas the green line is for a particle almost at ground level. The striking fact is that the green line goes into exactly opposite direction of the red line. The winds are blowing into different directions. At high altitudes, the winds are blowing towards the east, and at low altitudes, towards the west.
The Bravo commander expected fallout to blow towards empty ocean. Instead, most of the radiation was carried eastwards high into the air to descend on the USS Curtis, the Lucky Dragon, and nearby islands.
The major fraction of radioactivity is transported in high altitudes because the mushroom cloud lifts the radioactivity. I'm not sure whether they missed the information about the wind fields. but their impact on the fallout was probably underestimated.
The radioactive plume caused widespread contamination. On the islands to the east of Bikini, 260 people were quickly evacuated by the US military, but many showed clear symptoms of radiation exposure.
Usually before shots, they were very meticulous in predicting what the wind was going to do, but of course, winds can change very quickly. Just unfortunate.
There began, in this incident, a change in the view that the world had of these tests, and to some degree also of these bombs.
Bravo was 1,000 times more powerful than the Hiroshima bomb. But as relations between the superpowers reached a critical stage, scientists perfected a weapon of even greater magnitude. In Germany, in 1961, the flashpoint was over who should control Berlin. Soviet leader Nikita Khrushchev faced off against John F. Kennedy.
Khrushchev decided to do something about it and built the Berlin Wall, which came remarkably close to starting a war. Khrushchev called in his scientists and said, let's show the Americans what we can do.
What Khrushchev wanted was a 100-megaton bomb, the biggest of all time.
It was a deliberate threat. He said, let's build a really big one and show them what we can do.
The scientist Khrushchev summoned was Andrei Sakharov, the brains behind the Soviet bomb program for the last decade. Boris Altschula studied under Sakharov and was a close friend for 20 years.
He didn't consider it as some tool to kill anybody. It was a tool to defend us, our country, from being killed.
Sakharov had 3 months to produce the biggest explosive device of all time, dubbed the Tsar bomb, or King of Bombs. It had to be small enough to fit in a plane, yet still produce a force 6 times bigger than America's Castle Bravo. This would be a 3-stage weapon, rather than the 2 stages of the American bomb. An atom bomb would be the fission detonator, compressing the bomb fuel in first one thermonuclear reaction, but then another.
The scientists once thought about making a bomb that would be 1,000 megatons. And that would be a perhaps 4 or 5-stage weapon to get that much yield. It wouldn't be useful because once you get above 100 megatons, the fireball is the thickness of the atmosphere of the Earth, 10 miles. And any further blast is just going to go out into space. It's not going to do any good.
Sakharov was working under orders. But as the bomb neared completion, he insisted on one vital change. To limit the potential fallout, Sakharov amended the design to 50 megatons. Still, the most powerful object mankind has ever made was now ready to explode. The most powerful bomb ever produced, the Soviets' Tsar bomb, would detonate over the remote Arctic island of Novaya Zemlya. Mainly wilderness, the snowbound territory was far from centers of population to be affected by the bomb's fallout. As dawn broke, the crew assigned to carry out this historic mission were given their final briefing. Mission Control was a military airbase in northern Russia, 900 kilometers from the drop zone. The crew had been hand-picked, and their aircraft had to be specially adapted. The Tsar bomb, weighing 27 tons, had been fitted with a parachute and would be dropped from an altitude of 10.5 kilometers. The bomb would fall for 6,500 meters before detonating. Enough time, it was hoped, for the aircrew to escape the devastating explosion.
There were real concerns. Sakharov said, now they do something which was never earlier happened on the history and on the earth. To foresee exactly what will happen, the shock wave came to the airplane. An airplane fell down about a kilometer. But it was very high, so they didn't perish, but it was almost broken.
The most powerful man-made explosion in history produced a mushroom cloud which peaked at 64 kilometers, around 7 times the height of Mount Everest. Buildings 100 kilometers away were destroyed. Windows were shattered 500 kilometers away. Monitors who picked up the shock wave had been expecting something momentous, but nothing of this magnitude.
We were really impressed the fact that they were able to airdrop that thing. And even more impressed when we realized that had they used much more uranium in it, which they could have, it would have been 100 megatons. It was really amazing.
The implications were clear to the analysts. If the Tsar bomb were dropped on Washington, D.C. and detonated at an optimum height of 600 meters, the initial fireball would incinerate everything and everybody within 5,600 meters. People 20 kilometers away would suffer third-degree burns. Most buildings 30 kilometers away would be destroyed, releasing more than 3,000 times the energy of the Hiroshima bomb. It would kill over 1 million people instantly, perhaps 3.5 million in total. The altitude at which a bomb detonates is a critical factor. Dr. Martin Kalinowski was asked to determine what happened to the fallout from the Tsar bomb.
The big difference is that the Tsar bomb was exploded at 4 kilometers height, whereas the Bravo test took place close to ground. But there is a second issue about wind speeds and directions. This is a snapshot of the plume after 6 hours. Ground zero is marked here with the red star. Different colors are indicating the part of the plume at different heights. The important thing is there is no vertical transport, neither downwards nor upwards. The whole plume is traveling towards the east. Particles transported with fast wind speeds had no chance to reach ground. It took 48 hours before any fallout reached the ground. By that time, the very short-lived radioactivity had already decayed, and the concentrations were very low.
The low initial fallout of the Tsar bomb was still too much for the man who built it. Sakharov's own estimate was that 500,000 people worldwide would suffer in succeeding decades as the radiation deposited by the huge cloud slowly decayed. In a remarkable turnaround, Andrei Sakharov became a fierce critic of nuclear testing, until both sides agreed in 1963 to a treaty confining further tests underground to prevent fallout. The race for a superbomb was ended, and Sakharov was ultimately awarded the Nobel Peace Prize in 1975. But the legacy of this deadly contest is still evident on Bikini, which remains too radioactive for people to live there long term. Today, Bikini Islanders live elsewhere in the Marshall Islands, and some of them in the United States. Leaders of the exiled community, including the mayor, make periodic visits. This one, the first in 2 years.
Right now we are at the old graveyard site from before the testing was happening on Bikini. Bikini are all one family, so anybody dies, we all related.
The United States has, over the years, paid almost $200 million in compensation and in its attempts to clean up Bikini. But it looks like remaining an island of ghosts.
The children of Israel, they travel for 40 years. But children of Bikini, I really don't know if we will ever come back to Bikini.
The bombs laid waste one tiny island and helped shape history for the rest of the world. Does the man who played a key role from Hiroshima onwards have any regrets?
I never had any qualms that what we were doing was necessary at the time. But I've said many times politicians should have to get in their underwear and watch a megaton blast and feel the heat and really make better thinkers out of some of them.
Such a fascinating story. Now, just because they know the frozen highways of Alaska doesn't mean they can tackle the world's deadliest roads. Head-on confrontations with the locals too in brand new Ice Road Truckers tomorrow night at 8 here on Channel 5. Next tonight, a truly heartwarming story of courage. The woman who lost her face. Brand new Extraordinary People after the break.